this is like the only thing he missed on chapter 4 test. I'm like, this is supposed to be the easy day. So let's see how it goes. All right, so section 4.4. It sounds impressive. The fundamental theorem of algebra. The fundamental theorem. What did I say of algebra? Of calculus. Oh my goodness, of calculus. Fundamental theorem of calculus. You have to remember, back when they were kind of working with derivatives and trying to figure it all out, you know, they did the limits, then they saw some shortcuts. Some other people were dealing with area and different things. And it was a huge ordeal when they realized that the antiderivative dealt with the integrals. That was a huge, and that's basically what the fundamental theorem of calculus is. I mean, we kind of like, okay, we learned derivatives, we learned antiderivatives, oh, it's kind of cool, they go together. But for them, having no clue, they didn't even know. So having them realize, the mathematicians realize that this all does go together was huge. And so they finally wrote it down, the fundamental theorem of calculus. Okay? It actually has two parts. So the first part is the one we're going to work today. And the second part is the one we've already been talking about. So let's write it down. Oh, first of all, we have to say, technically, f, your function, f of x, is continuous on our interval from a to b. Okay. So long as f of x is continuous. If g of x equals the integral from a to x on f of t dt, then the derivative of g equals f of x. And you are just like, okay, now I understand why you didn't know what was going on. All this is saying is, I'm going to write it a different way. Let's get that written down. If g of x is this integral, okay, so if you take the integral, but then you take the derivative, you're right back to where you started. If you take the integral and then the derivative, you're right back to where you started. They're inverses, essentially. Okay, let's write it a different way. The derivative of this integral from a to x of f of t dt. So here you can kind of see, if I'm taking the integral, but then I'm taking the derivative, I am right back to f of, the only difference is because when I took the integral, I changed from t to x. So the only difference is it changes from one variable to another. But these functions, this f and this f are the exact same. They're the exact same thing. The only difference is this one's going to have t's in it, and your final answer is going to have x's in it. Okay? If you take the integral and then the derivative, you're right back to where you start. Okay? And we'll do some work that's what we're going to focus on today. The second part of this fundamental theorem of calculus is called the evaluation theorem. The evaluation theorem, we'll just abbreviate. Oh, okay, how are we going? Okay. And that's the one we've been using. If we have an integral from a to b, and this time we'll go back to f of x dx. If we have an integral, how do we come up with the answer? We take the antiderivative. Okay, so this one is going to be capital F, and remember you plug in b first, minus capital F of a. And that's really, I mean, they both kind of go together, but this one's really cool because they actually tie integrals. Remember, the capital F is the antiderivative. So they're tying in derivatives or doing the opposite of derivative with the integral. And like I said, that was huge. That wasn't like commonly known. They kind of had to realize that those two go together. So that's huge. So the evaluation theorem, that's the one we've been doing. okay, the last couple of days. So part 2, and that's probably the important one for the fundamental theorem of calculus. So they kind of go together because this one says you take an integral, then you take a derivative, you're right back to where you started. They're kind of like an inverse. One is talking more like an inverse. Okay, so anything else? Let's also write down this. I think we wrote this down before, and then we'll go back to this. But don't forget, if we have the integral from a to b, so this is something of f of x dx. What did we say happened if we wanted to change and put the b down here and the a up here? Does anyone remember? Right, remember it's because of this guy, right? Because we're subtracting. It would change it. Let's say here it was 5 and 2, the overall answer. If we did it the reverse, we would have 2 minus 5. So if we want to switch these, but actually keep them equal, we would put the negative sign out in front. And that would actually keep them equal. If you switch the way you're going to basically do the subtraction, you tag a negative sign along with it, and that flips it back. All right, what else? I think that's it. Okay, so let's talk about this first one. Let's take an integral and then take a derivative and see where we're at. So we'll do a small one because then we'll do some ones that are a bit harder. All right, so let's do g of x equals the integral from 4 to x of 3t squared dt. And we're going to find, let me slide this down. We're going to find the derivative of g. So we're going to take the integral because g is the integral. So we have to take the integral and then they're asking us to find the derivative. Take the integral and then find the derivative. All right, so how do we do the integral of this? Find the antiderivative, add 1, divide by the new. So add 1, and there's a 3 already there, and then divide by the new, that's going to give us 3. So my g of x is equal to t cubed, but I still have to go from 4 to x. Are we okay on that? Add 1, divide by the new on this. Takes us to t to the third, and then when we divide by 3, we get 1. Okay, and then g of x, what is that going to equal? We plug in x, so we have x to the third, minus, and then we plug in 4. So we add 1, divide by the new, we plug in the x, we're doing the f of b minus f of a, right? All right, and then 4 to the third takes us to 64. Now, what's the derivative? So that's still my g, I took the integral, now I want the derivative. The derivative is 3x squared. Roll it down, subtract 1, and the number goes away. The 4 ends up not playing a part, and that makes sense, right? Because the derivative of a constant goes to 0. So look at these two. With my original problem and my answer. If you take the integral and then take the derivative, you're right back to where you started. And that's okay, that's what we want to show. We want to show that those are inverses. They undo each other. The only difference is, what is the difference? They're not exactly the same. The difference is the variable, right? And that's kind of nice. It shows that I actually took the integral. Because when I take the integral, then this variable will pop up in my answer. But other than that, they're the same. The variable just changes, which is technically showing that I took the integral. Then when I take the derivative, I'm right back to where I started. And the number doesn't play a part. The constant falls out anyways. So let's take a look at one where maybe we don't know the integral. Let's do one where we don't know the integral. Or on your homework, are you going to have to take the integral and then take the derivatives? No, that's the whole point. We want you to realize that the integral and the derivative undo each other, and you're going to go right to your answer. Okay. So if I say, let's do a short one, and then I'll show you the directions. But let's say if I say find, let's keep the directions right now. Find the derivative of g. And I say that g of x equals the integral from 2 to x, 1 over t plus 1 dt. Straighten that over. Yeah. Okay, so I could take the integral and then the derivative, but we don't even know how to take the integral of this. But the whole point is to use that first step. What do I know the answer is going to be if I take the integral and then the derivative? The goal is for me to understand that if I do both of those, I'm right back to where we started. And then the only thing is, so my answer is this guy. The only thing is to show that I actually took the integral, I changed the t to an x. And so my answer is the derivative is 1 over x plus 1. There is no work, but that's because you know in your head that all the work undoes each other. And that's how they go together, the derivative and the integral, which was a huge deal back when they discovered it. Now we're kind of like, they're probably rolling in their graves. But you know, for them, I mean, that was their life, right? They were mathematicians, they were figuring all this out, and to them to actually put it together, they met their accomplishment and more, because they didn't even know that they were trying to fit these two together. Okay. All right. Let's do just a few more, and then we'll talk about, there's 2 ways to make it a little bit harder, but you don't have to write this down. The official directions are use part 1 of the fundamental theorem, we'll just abbreviate, theorem of calculus. What does it say? To find the derivative. To find the derivative. Find the derivative of the function. Which I think they're kind of saying, I think instead of just saying find the derivative, they're reminding you that you don't have to do any work. They're reminding you that, hey, don't forget, it's a theorem that says these undo each other and go right to your answer. Okay? But in essence, we are finding the derivative. All right, let's do, so we're finding the derivative. And g of x equals the integral from 0 to x. Actually, should I slow down? Are we okay on the directions? I'll write this slow. 0 to x square root 4 plus t to the 6th dt. Remember, whatever's in our function, this needs to match, because we're saying the width and then the height has to come from the same variable. Right? I need the width is an x width, or in this case a t width, and then my height has to come from us telling us what t value we want the height at. Okay, so these two have to match, which is going to kind of be key for tomorrow, for the next couple of days, and for Calc 2. These have to match, and sometimes we change one, which then means we have to change the other. They have to match in order for them to correlate. Okay, all right, so now what's this fundamental theorem? I'm taking the integral, but then I'm taking the derivative, so that takes me back to the original. That's my answer. The derivative, because g, first I have to take the integral, and then the derivative. And then how do I show someone that I actually took the derivative, or I took technically the integral? The x goes in its place. So 4 plus x to the 6th. All right, what about something like, okay, what about something like this? And this comes up, I don't know why it comes up early in the homework. G of x equals the integral from x to 4 of 3 plus t to the 7th and then to the 8th power dt. So what's different about this one? This is really when you go to your homework, just make sure you check this. It's flipped around, right? So you have to remember two things. Like, look here. This was x and then minus 4. If they're flipped around, it would be the number and then it would be minus x to the 3rd. And so your answer would actually then be negative. You see it? Okay. So what's the easiest way so that you don't have to really remember this? Just always put the variable on top. So the first thing I'm going to do is rewrite this. Probably the only thing I'm going to do is rewrite this. 4 and then x. But if I switch that, what else do I have to do? I have to put a negative out here. And that takes care of everything. Just make sure your variable's on top. That way everything flows. But we will take into consideration, I can't just switch those two because then I will get a different answer. If I switch those two and put the negative, then everything comes out okay. So just make sure that variable's on top and that'll get us our subtraction. Everything will be okay. And then what actually happens when I take the integral and then the derivative? I'm not just, yeah, question. You can't.
So on the test, are we gonna have to show our work how we do things?
No, right, no, I mean, and even, I think there's one of each on the test. So there's one straightforward, no work at all. This one, you might want to write it down, but I probably want to take off if you can do it in your head, say, hey, I have to switch these. And so the minus is going to go in front. Yeah, no, they're not worth a ton, but I did put like 3 on there. But yeah, you don't want to show any work. Yeah. Yeah. So this was just to show you that it does work or why it works. But yeah, the goal is to take the integral and the derivative, just go right to the answer. You know that they're going to undo each other. Yeah, good question. So this guy, just make sure that you bring this negative sign down. And then it's 3 plus x to the 7 and then to the 8. So just make sure if you don't switch this, then you kind of have to think it through on your own and realize that the x is going to have a negative in front of it. So it's easier just to do it at the beginning. Just catch that, put it at the beginning. Let's do one. Yeah, let's do this. Let's do 2 more like this, and then we'll go to the hard ones. Okay, all right, so let's do, okay, yes. G of x equals the integral from x to 7, and then it's 3t squared minus 2t plus 2 dt. I think maybe the student was confused because it looks like we're going right to the derivative. And actually, I don't want to do it yet. Do it. It looks like, though, when I write that, it kind of looks like I'm going right to the derivative. But what is g all by itself? G all by itself is the integral part. So just evaluating g is doing the integral, and then from there, I take the derivative. All right, how come I cross this out, though? What do I want to do first on this problem? I want to take the time to write g one more time and switch my limits. So I'm going to write g one more time, switching my limits. So that takes care of all my negatives and everything. And then I just have to remember right now to make it negative. So make sure that variable is on top. It just helps with all the negatives right away. And then I'm ready to go. Then I can take the derivative, and the negative sign just comes down, And it really matches, except to show that I did the integral, it changes from a t to an x. Make sure though, like a problem like this, you have the parentheses, okay? Because it goes to everything. Your other option then would be, if you want, you could definitely distribute. I'm okay if you just leave it, but understand that you might want to write both in your notes just so that you do have to have those parentheses. Now, did I do it right? Negative, positive, yeah. Okay. I'm okay if you put the parentheses, but understand that that negative goes to the whole thing. Just like here when I'm subtracting, right now here we only had one term, but otherwise this minus would go to the whole thing. Okay, how about, okay, so that's it. Okay, so let's do, let's do one more like this. Don't let, this is where we want the trig to pop up. Let's take a look. G of x is equal to x and then pi over 2 of secant squared theta e theta. We don't care about the trig because we know what our answer is going to be, right? The only thing is, catch it here. We always want subtraction. We always want to subtract the number so that everything's good. So let's write G one more time. Do we see how we want the x on top? We're still going to make it negative because we're not going to change the problem, but we're going to take care of all that negative at the beginning. If the x is on top, then you're good to go. If it's on the bottom, just take the time. All right, and then what is the derivative? Negative secant squared, but we're just going to do an x instead of theta. All right, one last thing we have to remember. Let's see. I want to start with trig. Yeah, let's do it. Okay. What happens if there's a quantity? Thought you were done with the word quantity? Never. Okay. So here we go. So let's take a look. G of x equals the integral from -4 to 3x squared, and then sine of t dt. So the x is in the right spot. I don't care that it's -4, as long as it's some number down at the bottom, sweet. So I can go right to my derivative. I'm going to take the integral technically, and then I go right to my derivative. So it is going to be sine of 3x squared. But because it's a quantity, what do you have to do with quantities, especially when you're taking the derivative? Times the derivative of the quantity. So we have to take the derivative of the quantity. So that's the only extra part whenever there's a quantity. And then that gives us, 6x, right? Sometimes I put this whole thing at the beginning. So that is 6x, but I'll put it at the beginning, 6x, and then sine of 3x. So just take your time when there's a quantity, just make sure you do the derivative of the quantity. This one, okay, that's not gonna go away. Let's do, and sometimes we'll finally change it. Instead of g of x, we'll change it to h of x. 2x to the 5th square root of 2 plus, and I don't know why they changed this to r squared. Usually we use t, but then this has to be dr. Now mark this one down, because this is the one we get wrong. Okay, the x is great. The x is right where we want it. We're taking the integral, then the derivative. We know we're right back to this answer. So, but to show that I took the integral, I have to plug in x to the 5th. The number doesn't even matter because when we do the derivative of a constant, it goes away. So I have to show, though, that I plugged this in. So x to the 5th and then squared. But I take the derivative. Now, what is this? This is going to be x to the 10th. You do not take the derivative of x to the 10th. You take the derivative of the quantity that you plugged in. So even though this is going to be x to the 10th, and maybe before we do that, why don't we write down, so that way we won't make a mistake at all. You write this down, and that's what you're taking the derivative of, the derivative of the quantity. So some of you, if you did that x to the 10th in your head, that's awesome, but then you might take the derivative of x to the 10th. Make sure you're taking the derivative of the quantity, which is x to the 5th. Right, but now we can set this up as the derivative right away. Let's go to our answer. Square root of 2 plus x to the 10th, but then it's going to be times 5x to the 4th. Yeah, it's not, I don't want to say it, I'm not even going to say it, but it's not the derivative of that guy. Okay, you have to take the derivative of the quantity. Match it here and here, because that's the quantity that you're putting in. If you want to write that first, just to make people happy, but either one's okay. Okay, so let's do 2 more and then we're done. So let's do, I'm back to g of x already. Integral of 5 to 1 over x cosine squared theta d theta. Believe it or not, taking the integral of like cosine squared, that's some crazy stuff. We say that for Calc 2. But I don't have to take the integral, right? Because I take the integral and the derivative right back to where we started. So that means that the derivative is, and my x is in a good spot, it's in the top. So that's great. I'm going to subtract my constant and that whole thing will go away when I take the derivative. So it is cosine squared of, what is it going to be? 1 over x. But then I just have to take it times the derivative. That's considered a quantity. Anything besides an x to the 1st is considered a quantity. Anything besides an x to the 1st, even like a 3x, right? Because what's the derivative of 3x? 3. Okay, so anything besides an x, because what's the derivative of x? 1. That's the only time that it's 1, and so we don't have to worry about it. Okay. All right, so the derivative of, now how come I'm not going to write 1 over x? Because I want to take its derivative, how can I write this? Same thing, but I'm just going to rewrite it as x to the -1. And so that is, don't forget, am I off the board there? Oh, okay. X to the -1. Okay, so then we're good. This guy isn't going to change. I could make this x to the -1, but I don't have to. But I do have to take this guy's derivative. What's that going to look like? Now, we haven't done that for a while. We're going to roll it down and subtract 1. So roll it down, subtract 1. Right here. There's a bunch of different ways to write this. I mean, you could even just write it like that. A lot of times this, I do move to the front. That's good. What else? I could move, where could I move that x to the -2? I could make it a fraction. It's probably good to just see. I could write it like this. I'll keep the negative on top and then put the x on the bottom. But if the x goes to the bottom, if this guy goes to the bottom, positive 2. That's more official, but to be honest, I like everything on the same line. So I actually like x to the -2. Again, they're probably rolling in their graves, but I like everything. I think because I'm a messy writer, so it just is so nice to have everything on one level. And if I'm going to do anything else with it, what's the first thing I do? Bring it to the top and make a negative. Okay. Last, should I change this? I think this might be our last one. Integral from 4 to 5x to the fourth t squared plus 3t and then dt. Oh, I have to say, technically, I should say that this is what? Technically, I should say that this is g of x. If I find, it's kind of nice to label. I mean, I guess I could technically say, I'm going to take the integral and then the derivative, but it's nice to label it so I can officially label it the derivative. It's always nice to have things labeled. Okay, where are we going with this? All right, so we are integral derivative. We're back right to where we started. So I think we can do the derivative. We're ready to go. It's going to be 5x to the fourth, that whole thing squared, plus 3 times 5x to the fourth. And then I had to take that whole thing, what do I still have to take it times? Derivative of that quantity, yeah. So the derivative of the quantity, I still have to take it times the derivative of 5x to the fourth. The whole thing. Okay, now what is this? Does anyone know how to, now let's just simplify it. Simplify it. It's not 5x to the 8th. I have to square everything that I'm plugging in. So it's actually going to be 25. Yeah, do we see that? I'm plugging in a quantity. I have to square the quantity. So 25x to the 8th. All right, here I don't have any exponent. But I can multiply those guys. So plus 15x to the fourth. And then that whole thing times the derivative, which is good. Yeah, some of you are saying good. 20x to the third, right? Roll it down, subtract 1. So remember, right now we're doing the derivative. And the answer is not good. You know, I would probably take that, but we can also distribute. Okay? If we did it by hand, if we actually took the integral and then the derivative, we would actually get, and this is one where we could actually do integral and then the derivative. So we would actually get 20 times 25 gives us 500. X to the 11. And then 15 times 20 gives us 300. And then x to, now we're multiplying. So what do we do when we're multiplying? Add those exponents, x to the 7. And again, I would take this, but this one we could do by hand, kind of like we did the first one, and then it would be like this. So don't panic with it. Let's do one more. I think it should be pretty easy. Let's do last one. Here we go. Derivative of integral from, let's do 3x to 4 of x. Let's just make it easy. Let's do x squared plus 7. Oh, and then, oh, no, sorry. Let's make this t. It's just kind of conflict. It's nice to have different variables. This actually says g of x, so that's okay because eventually I'm going to be putting in an x. All right, I made this one up on the fly, so I hope I like it. All right, so what do I want to do first? Yeah, do we see how this one we're going to flip? So I'm still going to call this g of x. Negative, let's flip it. Then we're in good shape, change that to a t. And then we're good, right? So we are going to, negative comes down, and then we're going to do 3x squared. You have to square everything. And then the plus 7. But 3x is considered a quantity, okay? Anything besides x. So I do have to take the derivative of 3x. And what is that derivative? That derivative is 3. So I can put the negative 3, if this is 2 derivative. So I'm going to put the negative and the 3 together. It's not 3x squared, it is 9x squared. You have to square the 3 and the x. And then that guy just did. That answer is okay. We could also distribute, right? Negative 27x squared minus 20. All right, so okay, wow, we finished early. Okay, so there's no work, right? But you still have to process yourself, and remember, you're just reminding yourself, if you take the integral derivative, they undo each other. They actually go together, which to them, huge discovery. Well, just one more thing we have to follow, right? All right, so work on that, see how you do. Hopefully that'll give you a little bit of time to maybe backtrack, or so there is a few on the homework, or there is a few on WebAssign, or just get it done, and then, you know, hopefully if you set your timer to 30 minutes, you'll get it done in less than 30. And if you don't, that's okay too. Take your time, then just get this one done.